For example 1, I'd like to add the following rational expressions. So anytime that you add rational numbers or fractions, you need a common denominator. So let's start there. Our denominators are x squared minus 9 and x plus 3. So I'm going to factor x squared minus 9. So this is 8 over, I know that's x minus 3 and x plus 3. And I'm adding to that 3 over x plus 3 because that's already factored. To make these two denominators comparable, I need an x minus 3 over here that's missing. That'll give me a common denominator. So all I'm going to do is just put another fraction here, and I'll put x minus 3 on the bottom, provided that I put x minus 3 on the top. What this does is multiplies by 1, so it doesn't change the value of the fraction, but my denominators are now exactly the same. I have an x minus 3 times an x plus 3. So if I want to add these fractions, I have my common denominator. It's x minus 3 times x plus 3. And you could write that as x squared minus 9, but I'm going to leave it alone for now. For the first fraction, I didn't do anything. But for my second fraction, I'm multiplying 3 and x minus 3. To complete this problem, I'm just going to distribute the 3, combine some like terms, and I'll pretty much be done. I have 8, I have 3x minus 9, and I'll write the denominator as x squared minus 9. So now I have 3x minus 1 over x squared minus 9, and there it is. I combine these into one fraction. There's no common factors to cancel, and this is what it is to add two rational expressions. So for subtracting rational expressions, same idea. You need a common denominator when you add. You also need one when you subtract. So here our denominators are x plus 7 and 2x. I think we can just multiply these two together and that should work. So the way I'll write this is, I have x and I have x plus 7, and I need to incorporate a 2x. And for my other fraction, I need the x plus 7. So here's my setup. By multiplying both these fractions by 2x over 2x and x plus 7 over x plus 7, I've not changed the value of the fraction because I've multiplied them both by 1. But I now have a common denominator of x plus 7 and 2x. But my numerators are going to be, I have x times 2x, which is 2x squared, and I'm subtracting 2 times x plus 7, which I'll write as 2 and x plus 7. So let's see. I'll distribute the 2. And I guess I can multiply out the denominators as well. So that's going to be 2x squared plus 14x. And I cannot simplify this any further. So this really looks a lot like example 1, where I just needed a common denominator and I added the numerators. The difference here is I'm now subtracting the numerators. Nothing cancels, there's no common factors, so that is it for this part of the question. And for the last example, again, just adding a couple of rational expressions, so I need a common denominator. Maybe this one won't be so obvious. Let's see. I think we're going to have to factor both of these to see how they compare to one another. So for the first fraction, I have x plus 1. And let's see, x squared plus 3x plus 2, that's x plus 1 and x plus 2. And for my second fraction, it's x divided by, okay, that's x plus 2 times another x plus 2. So actually x plus 2 squared. And if you look at both of your denominators, you just have to ask what is missing from both. So if I look at this first one here, let's see, there's an x plus 2 and x plus 1. I need a second x plus 2. So let's rewrite the first fraction. This is going to be x plus 1. The denominator I'll leave as x plus 1, and there's an x plus 2. It's just that I need another x plus 2. And for the second fraction, let's see, I have x plus 2 and x plus 2, but I need an x plus 1. So now I do have common denominators. In fact, a least common denominator. If I set up one fraction, I have one x plus 1, and I have an x plus 2. I have two of them, so maybe I'll just put a squared here. And for my numerators, I have x plus 1 times x plus 2, and I also have x times x plus 1. And at this point, like, the question's pretty much done. I just have to multiply out the numerators and combine some like terms. So let's see. I get x squared plus 3x plus 2 plus x squared plus x, all divided by x plus 1 times x plus 2 squared. And that gives me, I have 2x squared plus 4x plus 2 all over x plus 1 times x plus 2 squared. I'll leave my answer like this. I mean, the real goal is to write it, express it as just one fraction, and we just need a common denominator to do that.